Okay, this was a question. Air at 20 degrees Celsius, 40% of RH humidity flows over a water surface at a velocity of 1.4 meter per second. Length parallel to the flow is 200 meter and 200 mm. If average surface temperature is 60 degrees Celsius, it is average value. Calculate the amount of water evaporated per. So you want to find out the rate of evaporation. Rate of evaporation, that is conduction mass transfer. Take partial pressure of water vapor at 20 degrees Celsius temperature ഉണ്ടാകുമ്പോഴുള്ള pressure 0.011 and at 16 degrees Celsius ഉണ്ടാകുമ്പോഴുള്ള value 0.017. ഒന്ന് പറഞ്ഞു, what is at vapor stage, air stage ഒന്ന്. Next one is initial condition, then ഒന്ന് saturated condition. So saturated condition എന്താണെന്ന് ഞാൻ പറഞ്ഞിട്ടുണ്ട് ഇന്നലെ, ഫിഗർ വരച്ച് എക്സ്പ്ലെയിൻ ചെയ്തിട്ടുണ്ട്. That is saturated state means vaporization നടക്കുമ്പോൾ state and initial state. Viscosity mu is given, density is also given. So you want to find out the value of amount of water evaporated, that is my conduction mass transfer value, mass transfer rate. So our equation was HA into TS minus TL for heat transfer. So mass transfer വരുമ്പോൾ CA1 minus CA2 or rho A1 minus rho A2 എന്നും പറയാം. Rho A1 minus rho A2 or CA1 minus CA2. That is concentration is purely depend upon or really related to density also. So rho A1 minus rho A2 same one, CA1 minus CA2 is also same. So you want the equation is HA into TS minus CL. Here is HM into A into CA1 minus CA2. So HM is the mass transfer coefficient. A is the area. It is given to find out the value in per meter square. So area equal to 1 meter square. CA1 and CA2 value you want to find out. So given data നല്ല എഴുതി വെച്ചു. So പ്രോബ്ലത്തിലേക്ക് വരാം. So first you want to find out the value of HM, right? To find out the value of HM, you have the Sherwood number. Sherwood number equation is the Sherwood number equation use ചെയ്തിട്ട് നമുക്ക് കണ്ടുപിടിക്കുന്നത്, that is Sherwood number SH equal to HM into L by D. L by D. If question is L എന്ന് പറഞ്ഞാൽ എന്താ, full distance ആണ്. X by D എന്ന് പഠിച്ചത് നമ്മൾ, X is the distance, L is the whole distance, and if it's in diameter ഒക്കെ ആണെങ്കിൽ D by HM into L by D. So L is the length. നമുക്കറിയില്ല. Length is given. Length is given to 200 mm, it is 0.2 meter. HM want to find out. HM ആണ് കണ്ടുപിടിക്കേണ്ടത്. D is given and SH value want to be find out. SH value want to be find out. To find the value of HM, SH value ആണെങ്കിൽ this is a flow of flat plate problem. Flow over a flat plate. So we have our equations. Flow over a flat plate is SH. Three equations are there. That is first one for laminar flow, second one is for turbulent flow, and third one is for transition flow. So either first of all, we want to find out the value of RE value, Reynolds number and value, to confirm that whether it is a laminar flow or turbulent flow. ഏതൊന്നാണെന്ന് വെച്ചിട്ട് നമ്മൾ ഇക്വേഷൻ എടുക്കേണ്ടത് അല്ലേ. ഫസ്റ്റ് RE value നമ്മൾ എന്തായാലും കാണണം, ഇക്വേഷൻ കൊടുക്കണമെങ്കിൽ RE value കാണണം. അപ്പോൾ RE value കണ്ടുപിടിക്കുക ആദ്യം. RE value equal to rho VD by mu. Rho VD by mu. Here diameter is not given, length ആണ്. So rho VL by mu. Rho VD അല്ല, D is length ആണ് വേണ്ടിയുള്ളത്. Rho VL by mu. Rho is given. V അല്ല, velocity U ആണ് velocity അല്ലേ. Rho UL by mu. Rho UL by mu. Rho is density, it is given 1.22 into U velocity 1.4, it is given. Length is 0.02, it is also given, divided by mu. Mu value is also given 18.38 into 10 power minus 6. All values given. Density is given, velocity is given, length is given. Question viscosity, kinematic viscosity mu ആണെന്ന് എന്താണ് എടുക്കുക, UL by mu അല്ലേ. UL by mu എന്ന് ഇക്വേഷൻ ആയി മാറും, because rho by mu equal to 1 by mu. That is mu by rho equal to mu. the value 1.858 into 10 power 4 എന്നാണ് 1.858 into 10 power 4. That is ഇങ്ങനെ equation മാറ്റി. That is 5 into 10 raised to 5 is the critical point or reference point to find out whether it is laminar or turbulent. Rare. So RE value is whether it is less than or greater than of 5 into 10 raised to 5. The value is greater than or less than 5 into 10 raised to 5. RE is less than 5 into 10 raised to 5, right? The RE value is less than 5 into 10 raised to 5. So therefore the flow is laminar. So you can take the first equation. This equation. Not this equation. Equation because equation but here question is asking the average value, right? If average value of the value is in average form. So you want to take, so yesterday I said that for average value, the whole value will be doubled. For average value, the value will be doubled. So it is the case of average problem. So you want to take that equation into double form, that is SH equal to 0.664, 332,664 obviously, 332 RE raised to 0.5 into SC raised to 1 by 3 or 0.33, 0.3, 0.33, 1 by 3 or 0.33. So SC value, what is SC value? RE value കണ്ടുപിടിച്ചു കഴിഞ്ഞു. Okay, then SC value want to find out. SC value, SC by our definition, SC value was mu by D. Mu by D, right? What is mu? Mu equal to mu by rho, right? Viscosity divided by density. Viscosity divided by density is mu, Kahneman viscosity. Okay, so SC value will be mu by rho into D. Mu by rho into D equal to 18.38 into 10 power minus 6 divided by rho is 1.22. 1.22 into D. D is the diffusion coefficient. It is given as 0.256 into 10 power minus 4. അല്ലേ ക്വസ്റ്റ്യൻ തോന്നിയിട്ടുള്ളത് D value 0.256 into 10 power this value. You can find out the value of SC. Substituting the value of SC in this equation, you can find the SH value. By substituting the value of SH in that particular equation, you can find the HM value also directly. If a question asking this in format, the first thing you can want to find out is RE value to find whether the flow is laminar or turbulent. If laminar, you can use the equation. If turbulent, you can use another equation. If the question is asking for average value, you want to double that equation. The flow is, if the question is asking for a flow through pipe ആണെങ്കിൽ എന്താണ് flow through pipe ആണെങ്കിൽ ഒറ്റ equation ആണ്, നമുക്ക് വേറെ ചെയ്യേണ്ട ആവശ്യമില്ല. There is one equation. The single equation is that is 0.023 into RE is 0.83 into SC is 0.44 before. Okay, substitute കണ്ടുപിടിക്കുന്നില്ല, നിങ്ങൾ കണ്ടുപിടിച്ചോളൂ. Find the value of SSC. After that, substitute the value of SSC SH 0.664 into RE. RE raised to 0.5, that is root of RE, into SC raised to 0.33. RE is 1.858 into power raised to 4, and SC value want to be found by using this equation. You will get a value and substitute the value of this equation to find out the value of SH. The Sherwood number will be 75.846. 75.846. By completing the whole calculation, you will get the value as 75.846. SH Sherwood number. Okay, then we know that Sherwood number equal to HM into L by D. Therefore, HM equal to SH into D by L. SH is 75.846. D is 0.256 into 10 power minus 4 divided by length is 0.22. You will get the HM value. HM value meter per second. Zero point two two 0.200 meter ആണ് അപ്പോൾ 0.2 0.2 0.2 HM will be 0.00971 meter per second. 0.00971. SH value will be 0.0097 meter per second. Okay. HM കിട്ടി. Then you want to find the CA1 and CA2 value. CA1 and CA2 value. For that, yesterday I said that CA equal to concentration. Concentration is nearby equal density itself. It is also called density itself. Density concentration is same one. Okay, then we can say that CA equal to rho A itself. CA equal to rho A itself. CB equal to rho B itself. CA1 equal to rho A1 itself. CA2 equal to rho A2 itself. So according to the equation, PV equal to rho RT. PV equal to rho RT. Equation ആണ്. PV equal to MRT, mass density over volume. P equal to RT ആണ്. Then PV equal to MRT. നമുക്ക് അങ്ങനെ equation PV equal to rho RT കിട്ടും. Right? Okay. PV equal to rho RT. Therefore, rho equal to CA1. Therefore, implies rho equal to PV by RT. Rho equal to PV by RT. Rho is another by equal to rho A equal to CA itself. Therefore, CA1 or rho A1 equal to PA1 into volume ഇല്ല കേട്ടോ. P equal to rho RT. P equal to rho RT. P equal to rho RT, not V is there. Because the equation is PV equal to MRT. PV equal to MRT was our equation. And you can, mass equal to density equal to mass by volume. That equation എഴുതി കഴിഞ്ഞാൽ V അടിയിലേക്ക് കൊണ്ടുപോയി കഴിഞ്ഞാൽ P equal to M by V into RT. P equal to M by V into RT. So the equation became P equal to rho RT. P equal to rho RT. P equal to rho RT. Therefore, rho equal to P by RT. Rho equal to P by RT. P by RT. Therefore, PA1 divided by R into TA. Initial condition. Therefore, CA2 or equal to PA2 divided by R into TA2. Second condition. Therefore, pressure and temperature for first condition and pressure and temperature second condition is given here. Okay, that is first condition for water condition and saturated condition. S condition, A condition തന്നിട്ടുണ്ട്. Okay, you want to find out the R value. R is a constant value. That is characteristic gas constant value of the question is for water surface. To find out the value of R of water ആണ് കണ്ടുപിടിക്കേണ്ടത്. R of air ആണെങ്കിൽ നമുക്കറിയാം 0.287 ആണ്. R equal to water equal to 0.287 kilojoule per kilogram Kelvin. Therefore, to find out the R of H2O, that is R of water കണ്ടുപിടിക്കണം. R of water. രണ്ട് കേസിലും R of water want to be find out. That is, there is an equation for R. I think you are studied in thermodynamics. Sorry, R equal to characteristic gas constant equal to R naught by M. R equal to R naught by M, where R naught equal to universal gas constant, and M equal to molecular weight. Okay. R equal to characteristic gas constant. In some equation, it is taken as G. R naught equal to G. G equal to R naught equal to. G equal to R naught equal to characteristic gas constant. So we can get R equal to R naught by G or R naught by M or R G by M. Okay. To find the R of H2O equal to G of H2O divided by, G is a constant, G divided by M of H2O. Molecular weight of H2O is 18. H2O 18. എങ്ങനെ കണ്ടുപിടിക്കുക? H2O. H2 means H equal to 1, H2 is equal to 2 plus O equal to 16. Oxygen atomic weight 16, 16 plus 2, 18. Therefore, molecular weight of water is 18. Gravitation constant of is 8.314 kilojoule. 8.314 joule divided by 80 will be the R of H2O. This is a familiar equation. അതുകൊണ്ടാണ് ഞാൻ കൂടുതൽ പറയാത്തത്. It is a familiar equation which is R equal to characteristic gas constant equal to universal gas constant divided by molecular weight of the component. Here you want to find out the R of water. Water ആണ് evaporate പോകുന്നത്. You find R of water ആണ് കണ്ടുപിടിക്കേണ്ടത്. R of water means universal gas constant 8314 joule per kilogram Kelvin divided by its molecular weight 80. R of H2O will be കിട്ടും. That is 461.9 joule per kilogram Kelvin. That is the R value of water. Substituting that value of R, you can find the CA1 and CA2 directly. CA1 and CA2. CA1 അല്ല, CW of A minus CW of S ആണ്. അല്ലേ? CW of A minus S ആണ്. Initial condition and saturated condition. Water. So first one, CW of A or CA1 equal to PV by RT, that is PWA divided by R of H2O into T, temperature, WA. That is the air first condition. A condition, PWA equal to 0.017 bar into 10 power 8 Pascal. 0.017 bar ആയിരുന്നു, it is 10 raised to 5 Pascal divided by R of H2O. It is find out as 461.9 into TWA. At that temperature, what was that temperature? It P equal to 0.17 bar. 20 degrees Celsius. 20 plus 273 Kelvin will be the CA1 value or CWA value. And CA2 value is CWS is equal to PWS divided by R of H2O into T of WS equal to, the pressure was 0.011 bar into 10 power 5 Pascal. Pascal മാറ്റി. R of H2O was 461.9 itself, and into the temperature will be, at that time temperature is 16 degrees Celsius. 16 degrees Celsius. That is 16 plus 273 will be the CA2 value. Find out the value. And finally, you can find the value of mass diffusion or mass of evaporation per area equal to HM into area into PWA minus CWS. or higher value minus lower value. But which is higher value, that minus lower value. Okay, higher value ഏതാ കിട്ടുന്നത് വെച്ചാൽ അത് കൊടുക്കുക. CWS ആണെങ്കിൽ CWS. ഫൈനൽ മൈനസ് ഇനീഷ്യൽ ആണ്. ഫൈനൽ മൈനസ് ഇനീഷ്യൽ ആണ്. CWS minus CWA. Area is 1 meter square. Therefore 1. HM കണ്ടുപിടിച്ചു കഴിഞ്ഞു. HM is 0.00971 into 1 into that value. CA1 value is or CWA value is എത്ര കിട്ടിയത്? എത്ര കിട്ടിയത്?
0.01.
0.01 0.01 ആയിരിക്കില്ലല്ലോ. ശരി 0.0127. 0.01 മാത്രമേ എഴുതരുത് കേട്ടോ. ഡെസിമൽ പോയിന്റ് എത്രയുണ്ട് മാക്സിമം എഴുതണം. കണ്ടോ 27 കൂടി
0.0125.
25 ആണ്. 25 നിങ്ങൾക്ക് കിട്ടിയ വാല്യൂ എഴുതാൻ എഴുതി വെക്കാം. 25 കിലോഗ്രാം പെർ മീറ്റർ ക്യൂബായി. എന്തായിരിക്കും? ഡെൻസിറ്റി തന്നെയാണല്ലോ. CA1 ഈക്വൽ ഡെൻസിറ്റി തന്നെയാണല്ലോ. അപ്പോൾ ഡെൻസിറ്റിൻ്റെ യൂണിറ്റ് തന്നെ ആയിരിക്കും കിലോഗ്രാം പെർ മീറ്റർ ക്യൂബ്. CA2 എന്താണ്? 0. 0.008 ആണ്. 0.00813 ആണ് ടെക്സ്റ്റ് ബുക്കിലുള്ളത്. 8.3 കിലോഗ്രാം മീറ്റർ ക്യൂബ്. CWS അല്ലേ ഇത്? CW 0.011 10⁴5. കിട്ടിയ വാല്യൂ ഒന്ന് എഴുതി വെക്കാം. ഇതിനകത്ത് ഹയർ വാല്യൂ ഏതാണെന്ന് വെച്ചാൽ ഹയർ വാല്യൂ എഴുതുക, ലോവർ വാല്യൂ എഴുതുക. ഹയർ വാല്യൂ മൈനസ് ലോവർ വാല്യൂ ചെയ്യുക. CWS മൈനസ് CWA ആണെങ്കിൽ അത് CWA മൈനസ് CWS തന്നെയാണല്ലേ. ഹയർ വാല്യൂ ഈസ് ദിസ് 0.012. will be your answer. In kilogram per second ആണ് ഉത്തരം കിട്ടുക. കിലോഗ്രാം പെർ സെക്കൻഡ് മീറ്റർ ക്യൂബ്. Your answer will be in kilogram per second into meter cube. Kilogram per second meter cube. Meter square. Kilogram per second meter square will be your answer. Okay. Kilogram per second meter square will be your answer. And the question is asked to find out the value in kilogram per hour. Right? Question വായിച്ചോക്കെ വാട്ടർ per kilogram per hour meter cube. Per hour meter cube. Hour per meter square. Here it is second per second meter square ആണുള്ളത്. Second meter square. Okay. Kilogram per second meter square is here. You want to convert into hour. To convert into hour, you just want to multiply into 60. It will be second into 60 കൊടുത്തു കഴിഞ്ഞാൽ മീറ്റർ ആവും, അല്ല മിനിറ്റ് ആവും. അഗെയിൻ ടു 60 കൊടുത്തു കഴിഞ്ഞാൽ ഇറ്റ് ഈസ് ഇൻ ഹവർ. Therefore, the total കിട്ടിയിരിക്കുന്ന വാല്യൂ the answer multiplying 3600 to get the equation in kilogram per hour meter square. To convert into hour, you just want to multiply the value into 3600. That is 60 into 60. First you multiply in 60, you will get into meter, minute per meter square, and again we multiply in 60, you will get it in hour. Therefore, to multiply the value in 3600, you will get the value in hour. Okay, that is the question. The question simply means the equation to find out the heat transfer rate or mass transfer rate into convection. So our equation is simply h into a into ts minus t alpha. Other equation then, that is in mass transfer it become hm into a into ca1 minus ca2, or if the density ആണെന്നുണ്ടെങ്കിൽ rho a1 minus rho a2 itself. Rho minus rho a2. Initial pressure and temperature വെച്ചിട്ടുള്ള rho കണ്ടുപിടിക്കുക, at is c കണ്ടുപിടിക്കുക, then final temperature pressure വെച്ചിട്ടുള്ള rho 2 or ca2 കണ്ടുപിടിക്കുക, then higher value minus lower value will be your answer. Higher value minus lower value answer ca1 minus ca2. And hm value you want to find out by using Sherwood number. Hm value want to be find out using Sherwood number. Why find out the Sherwood number? You just want to know whether the flow is laminar or turbulent. To find out the flow is in laminar turbulent, you want to use Reynolds number equation. After finding Reynolds number, and by evaluating, you can find out whether which equation you want to use. The question is asking an average value, you want to double the value and find out the hm value. Hm value, ca1 and ca2 value together find out, you will get the value of evaporation rate in convection heat transfer. That is a problem related with the convection heat transfer. ഇനി നമുക്ക് പിന്നെ സമയം ഉണ്ടെങ്കിൽ നമുക്ക് ഇതിന്റെ വേറെ ക്വസ്റ്റ്യൻസ് ഉണ്ടെങ്കിൽ ചെയ്യാം. ഓക്കെ, ഈ ഒരു മെത്തേഡാണ് പ്രോബ്ലം വരിക. റൈറ്റ്, ദിസ് മെത്തേഡ് convection heat transfer, convection mass transfer problem will be asked. Okay, then our last theory to take is the heat transfer and mass transfer. Heat transfer and mass transfer analogy. Heat transfer and mass transfer analogy. What is simply analogy means? Analogy means that relation or comparison itself. Okay, ഞാൻ ഒരു കാര്യം പറയാം. The equation of the particular analogy of heat transfer and mass transfer in the case of convection ഞാൻ പറഞ്ഞു. That is, for heat transfer it is Q equal to HA into Ts minus T alpha. And the same case in mass transfer is Q or m dot or m by A or something m dot equal to hm into A into Ca1 minus Ca2. This is the analogy between heat transfer and mass transfer in the case of convection transfer. Okay, for convection transfer it is HA into Ts minus T alpha, and this mass transfer it is hm into A into Ca1 minus. It is the analogy. ഇതിനാണ് അനലോഗി എന്ന് പറയുക. ഒരു ടേം മറ്റൊരു സംഭവത്തിൽ ഇക്വേറ്റ് ചെയ്യുക. ഒരേ ഇക്വേഷൻ തന്നെ രണ്ട് കേസിൽ ഇക്വേറ്റ് ചെയ്യുന്നതാണ് what it is called analogy means. So you want to find out the analogy between heat and mass transfer. Analogy between heat and mass transfer equations. In the case of, there are two analogy. That is, first one is Reynolds analogy, and second one is Colburn analogy. രണ്ട് ചെറിയ ഇക്വേഷൻ മാത്രമേ ഉള്ളൂ, Colburn analogy and Reynolds analogy. In the case of Reynolds analogy, there are two equations. That is, first one is Reynolds analogy for heat transfer and mass transfer. Reynolds analogy for heat transfer and mass transfer is Nu divided by Re into Pr. Set number divided by Reynolds number into Prandtl number equal to standard number. Okay, in the case it is standard number. For mass transfer it is H by rho into Cp into Cp by U. It is called Cf by 2. It is the Reynolds analogy to find out the relation between that equations into friction factor of Cf. Friction factor of Cf by the relation ആണ് പറഞ്ഞിരിക്കുന്നത് Reynolds analogy. In the case of heat transfer and mass transfer, the heat transfer equation total a relation of that particular non-dimensional equation into friction factor, അതാണ് Reynolds analogy. ഇത് in the case of heat transfer. And in the case of mass transfer, the equation is SH by Re into Sc, Sherwood number divided by Reynolds number into Schmidt number equal to STM. STM means simply ST itself. ST means standard number in heat transfer. It is standard number for mass transfer in mass transfer equation. STM എന്ന് പറയും. That is equal to HM by U. HM by U is also called CF by 2. This is the heat transfer and mass transfer analogy for Reynolds analogy. Reynolds equation വരുന്ന analogy. It is the relation between Reynolds number and that particular friction factor CF in the case of convection heat transfer or convection mass transfer. It is related to state number. ഇവിടെ നെസറ്റ് നമ്പറും റെയ്നോൾഡ്സ് നമ്പർ PR നമ്പറാണ് ഉപയോഗിച്ചെങ്കിൽ ഇവിടെ ഷെവേർട്ട് നമ്പറും റെയ്നോൾഡ്സ് നമ്പറും ഷെമിറ്റ് നമ്പറുമാണ് വരുന്നത്. In the case of heat transfer and mass transfer, it is the Reynolds analogy. And the equations എന്താണ് പറഞ്ഞിരിക്കുന്നത് നമുക്കറിയാലോ, ഓരോ കാര്യങ്ങൾ എന്തൊക്കെയാണെന്നുള്ളത്. That is SH equal to Sherwood number, R equal to Reynolds number, SC equal to Schmidt number, STM equal to standard number, HM by U, CF equal to friction factor, HM equal to convection mass transfer coefficient, meter per second. That is a Reynolds analogy. In the case of heat transfer and mass transfer, it is a relation between Reynolds number and friction factor CF. It is only valid when the condition where PR equal to SC equal to 1, Random number equal to Schmidt number equal to 1. Okay, PR equal to Schmidt number equal to 1 and the condition is മാത്രമേ this Reynolds analogy is valid. PR number equal to Schmidt number equal to 1. Okay, if it is not unity, if it is not 1, there is another analogy called Colburn analogy. Colburn analogy is used when is PR equal to SC equal to not equal to 1. Not equal to 1 എന്ന കണ്ടീഷനാണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്. That is the equation is Colburn analogy. J of HT, that is Colburn analogy notation, J of equal to ST into PR raised to 2 by 3 equal to CF by 2. Okay, for heat transfer. And J of MT means mass transfer. This HT heat transfer, MT mass transfer. STM into SC, PR number SC 2 by 3 equal to CF by 2. This is for mass transfer. Here J of J equal to Colburn analogy, Colburn coefficient. J of HT means for heat transfer, J of MT means mass transfer. So combining those two equations together, you will get the analogy to heat transfer of mass transfer. Coefficient of heat transfer mass transfer analogy will be H by HM equal to rho Cp Lewis number raised to 2 by 3. Lewis number raised to 2 by 3. H by HM equal to rho Cp Lewis number raised to 2 by 3. Where Lewis number equal to alpha by D. Or SC by PR. LD equal to alpha by D or SC by PR. Okay, rho Cp. So what is the analogy between heat transfer coefficient and mass transfer coefficient is H equal to rho Cp Lewis number raised to 2 by 3 into HM. HM അങ്ങോട്ട് എടുത്തു കഴിഞ്ഞാൽ you can say this is the analogy between heat transfer coefficient and mass transfer coefficient between H by HM equal to rho Cp Lewis number raised to 2 by 3. Okay, that is the last theory in this module. This heat transfer and mass transfer analogy. There are two analogy, Reynolds analogy and Colburn analogy. These two are related to friction coefficient CF. Heat transfer to mass transfer. Reynolds analogy is valid only when PR equal to SC equal to 1, and Colburn analogy is valid when it is not equal to 1. Okay, then together we can constitute the heat transfer coefficient and mass transfer analogy, that is HM by HM equal to rho Cp LE raised to 2 by 3. The theory is in your hand notebook, and also it will be given as a PDF. So we can wind up the session.